Now that we understand the setup for input, output, and power efficiency, let's take a look at some of the component level issues that would cause that efficiency to drop. The primary causes of power loss in a power system are the power switches and the magnetics. Understanding the switching and conduction losses along with magnetic losses makes it possible to optimize the overall efficiency of the system. In order to accurately measure switching and conduction losses, you have to measure the voltage across the switch, usually called VDS, and the current flowing through it, usually called ID. In order to do this, I've connected my TMDP0200 voltage probe across the drain and the source, as well as the TCP0030 current probe to the FET current. It's also quite common to activate the switches using an external AFG, such as this AFG 31000 with isolated outputs, when the drive circuit is not verified. We don't have that issue here, so we're just going to use the drive circuit on the board. Note that this might not be a viable option for a lot of fast switching circuits, such as the ones with GaN or SiC technology, as the packages are tiny and the current loop might degrade the performance. In that case, we would use a high bandwidth, high CMRR probe, such as the IsoView, and make current measurements through a shunt. Now that we have our VDS and ID set up, we can turn on the switching and conduction losses feature in our 4Power software. This makes it easy to look at the losses as well as the other timing parameters, as you can see on the screen. Magnetic analysis is available on the 5 and 6 series MSOs in the 5-power and 6-power options. Having the rest of the system set up at this stage makes it easy to debug issues at every line and load level, and makes it convenient to test every critical measurement at the same time.